Yes, the thing is, for the test one, I promised I will send you the solutions.
Yeah.
But then professor said, no, we will not provide these solutions. So professor, the course coordinator said that. So
Okay.
sorry, I couldn't send that. The thing is, what I have here, whatever the notes I will make on my tab, I will send them. And I will also upload the recording as I did last time.
Okay. Thank you.
Are we doing the practice questions posted on in detail, or are we doing the 216 midterm? So let's do the test too, because last time I did the midterm and there was too much demand for the test. So first we will do the test. Just give me 1 minute. So I'm going to share my screen with you. So I can't share screen. Share screen and why cable share it. Okay. Can you see my screen? Hello, can you see my
Not yet, not yet, no.
No.
Not yet. Okay.
It says you've started sharing, but nothing's popped up yet.
Yeah. Again, screen share. Now can you see it?
No, same thing.
Now can
There,
you?
and we can see it now,
Got
yes.
it. Works.
Yeah, fine, fine. Okay. So should work like this. So here we go. We are ready for that. So first practice question was that solve the system of DE by systematic elimination. So it is, okay. Question 1. 2D minus 5 into x plus dy is equals to 1, and d minus 1 into x plus y is equals to 2. So this is our question. What do you think how we will do it? Okay, people are chatting. So
Multiply the second equation by D and subtract it from the first one.
yes, we will. Thank you very much. It is D, not 1, and which shows that I can't see properly. So yes, it is D. So let's multiply. We have y here simple. So let's multiply the equation 2 with D. So equation 2 multiplied by D, we have D into D minus 1 x plus dy equals derivative of 2 is 0. So it is 0. My mic is mute? No, my mic is fine. Can you hear me?
You're fine. You're fine. Don't
I
worry
can
about
hear
it.
you.
So now we will subtract equation. This is our third equation, this is our second, and this is our first equation. So subtract equation number 3 from 1. We will have 2d minus 5 minus, it becomes d squared minus d, and this is x. Keep an eye on the mistakes. We can make mistakes. So dy will be cancelled and it is equals to t. Fine. So now we will solve it. So this is minus d squared plus d plus 2d, which equals to 3d minus 5. X equals t. Till here, any question? Derivative of 2 is 0. That's why it is 0. This 0, it is because we take the derivative of a constant and it is going to be 0. So here we will write it as minus, we can take common, t squared minus 3d plus 5 into x equals to t. Now what we will do here? We will find xc and xp. Fine, our particular component and the homogeneous component. So for the homogeneous component, we have d squared minus 3d plus 5 equals to 0, which means what we will have, so what we will have here, question I have solved it, so let's do it. So Let's derive it. So then we have d square, let go up. So it will be equals to, in this case, we have 3 plus minus 9 minus 4ac is 20 divided by 2a, that is 2. So it will become 3 plus minus 11 under root iota divided by 2. So our real part is 3 by 2 and our imaginary part is 11 under root divided by 2 iota. So this is our xc will be equals to c1 e raised to power 3 by 2 cos of 11 under root by 2 t plus c2 e raised to power 3 by 2 sine of 11 under root by t2 2t. Any question till here? No, okay, fine. So for the xp, we have t in the equation, so it will become at plus b. X prime will be a and x double prime will be 0. So we will put these values into this equation. This is our equation 4. So equation 4, putting values, okay. I should write it first, but putting values in equation 4, we get 0 minus 3d. So this is minus 3 into a plus we have 5. So it is 5 into at plus b. Okay, equals t. So this way we have minus plus 3a minus 5at minus 5b equals t. If I'm not wrong, you can keep the eye on the mistakes because my screen is moving and you are writing on the paper. So you can have good judgment. 3 plus minus 9 minus 20 is fine. And then we are here. So we have 3a minus 5b equals 0 and minus 5a equals 1. This implies a is equals to minus 1 over 5 and b is equals to, okay, 3a minus 5b, sorry, we have, what I'm doing. So we have the a value, so let's write 3 into minus 1 over 5 minus 5b equals 0. So 5b will be equals to minus 3 over 5. So it is 25. And you can put it back. Okay, if you can't hear anything, maybe your speakers are down. Check it. How did you get XP? So if you look here on our equation 4, this is our equation we made. Okay. This part will give us yc equals to 0. When we will solve it, we will have homogeneous equation. But on the right side, we have t. So when we have t, we have just one variable. And for that, when we define xp, we define it as at plus b. If you remember it from the last, in the initial labs. Okay, was so any question? I can't hear properly. Can you say it again? Okay, Moaz Alam, I think you did not on the audio. Your audio is not joined. That's why you cannot hear me, and you are not properly logged in. So, um, okay, fine. That's great. So, any other question about this? Okay, if I miss any question, let me check the chat. Okay, so if you want me to scroll it down, I will give you the notes, but if you want me, can you explain how you find A and B again? So again, we will go here. So what we do when we have systemic equations, we try to make one equation in one variable form. So here we had the two equations, 2d minus 5x plus dy is equals to t, one equation. And the second was d minus 1 multiplied by x plus y equals to 2. Fine. Now d is the operator, you know that. So to make it, sorry about that. So, okay. So we were talking about here. Now to make it equal so that we can cancel one variable, we will multiply and divide by something which can make two equations, at least one variable equal on both sides. So here we have multiplied by t here. We multiplied by d. Now when we multiply, it is a derivative, it is d by dx, fine. So it is 0. Now after that, now we have one equation, this is one equation, our equation 3. Okay. Based on that, no, this is our equation which we have multiplied, and now we will subtract 3 from 2 to get one variable form equation. And for that, we have gotten equation number 4. So now we will solve according to equation number 4 so that we can have xt. When we will have xt, we will put that value in and one equation, one of the equations to find yt. Now here our equation 4 is minus d square minus 3d plus 5. Minus is common out. X is equals to t. So first we find the homogeneous equation, which was something bigger. So you can solve it. If there is mistake, you can find it. So it is c1 e raised to power 3 by 2 cos of square root of 11 divided by 2t. So this is our equation for the homogeneous part. Okay. For the particular solution, we have t on the right side. So we have taken at xp is equals to at plus b. We will take polynomial here equation. So we will find the x prime p, which is equals to a, and x double prime p, which is equals to 0. After this, in this equation number 4, we will apply our values for d2x minus 3d plus 5. They are derivative of x. So for instead of d2, I applied here x double prime p, here x prime, and for with y, we will multiply with x. So after this, we reach here and we find, by solving it, we find comparing the coefficients. So I will write here comparing the coefficients so that you can get it. You will find A and B. Okay. Why do we use AT plus B? If we go into when we started these equations, we decided that when on the right side, we have single X or Y or Z or whatever. So we take a polynomial equation, which is AX plus B or something like that until we have constant. For example, if you have T square on the right side, you will take AT square plus bt plus c until you t becomes 0. Yes. Okay. Any other question? So it is minus 3, maybe it is minus 3. I am wrong. Yes, it is minus 3. You are right. Check it out. So if there are some little bit mistakes in calculations, try them again and you will find it, okay? So now we can start question number 2. Okay, let me go back to white color. Question number 2. Any other question about question 1? Okay. Question number 2, evaluate the Laplace transform. So we have Laplace t, and we have integral 0 to t. What was the final solution? So final solution, you will put the values of a and b, and then you will write, okay, let me tell you. This is x of t. You will write xc plus xp, okay? And then you will find y of t by using the x value. If you want, we can go there, but it is easy part. You can do it by yourself. If you want, I can solve it further. Do you want me to solve it? Can we do it together,
No,
please?
no, that's fine.
Can I ask a question?
Yes.
In the case that you can't use that trick, or you plug just the one of them, like if you solve for one and what if you can't do that trick? What in that case you'd need to solve the system for both of them, right?
Yes, but hopefully the questions which will be given to you will be in the in our scope.
But if it's not like that, then how would you make sure that you don't have extra constants in your equations, if that makes sense?
So in that case, we try Laplace really.
So basically it's like really difficult if you can't plug it back in, basically.
Yes, I mean, this is another way to solve the equations. We are learning so many methods in this. You remember variation of parameters and other things we have learned already. So
Yeah.
this is one way to solve the differential equations.
Okay.
Okay.
Could you give us the final answer for question 1, please? You don't need to do it. I would just like to know what the actual answer is.
Answer. Let me see if I find it, because your professor told me no, do not give these solutions. So I am trying to do it as small as possible. But to
Like
help
literally
you,
just what x is and what y is. That's what I'd like to know. Just like what x of t is and y of t is. The final answers, if you would.
so I don't have the final answer with me. No, I don't have the final answer with me at the moment. I solved it here till here. If you want, I can do it with you. Do you want to do it?
It's not that I need you to do it with me. Is I wanted to have the final answer so that when I did it myself, I'd be able to make sure I actually did it right.
Yeah, yes, I didn't solve it, so I don't have the solution. If you want, we can solve it together, but I'm very sure that you can guys do it. It's so simple.
Yeah, I'd rather go on to the more complicated questions.
All right, let's go.
So
Next
let's
question.
do the second question first. And I lost my paper, so I got it. In the second question, we have this one. This looks very difficult. This looks terrifying, but it is not. It is easy question. In fact, t e raised to power minus tau d tau. So this is, we have to find the Laplace. What do you suggest? What should we do here?
Convolution
Convolution.
and the derivative t trick or whatever.
Derivative trick. So the thing is, let me share. Laplace of t f of t is in fact minus d over ds Laplace of f of t. This is the trick we are going to use here, okay? So which
Can't we just evaluate
you
the
can
integral?
do, sorry?
Can't we just evaluate the integral?
Say it again.
Because t is a constant in the integral, so you could take it out and then you could just do the integration, right?
Yes, we will do that, but we have to take the Laplace, okay? So here we have this formula and it will make our life easier. So we will use it, okay? And that will work, okay? So here we have minus d by ds from here. Based on this t, this is our f of t, okay? So we have Laplace of 0 to t, e raised to power minus tau d tau. And this t is constant, you are right, we will take it out. So I can take it out here and it comes here, fine?
Yep.
That's fine.
Yeah.
So let's now with this t, we have minus d2 over ds squared, Laplace of 0 to t, e raised to power minus d tau. Fine. Any question? Now we have integral with us. So we will solve it and we will have minus d2 over ds squared.
Wouldn't it be positive now?
Sorry?
Could-
What happened to the other t?
Wouldn't it be positive now because you multiply by -1 again?
Yeah, it will be positive. You're right. Thank you very much. It is positive. Someone said something else.
What happened to the other t? There was a different t in the question as well.
Yeah, this is to show you, to confuse you. Okay, look, here our variable is tau, okay? So the t will be a constant, so you can take it out.
No, not that t. The other t.
The other t it is the question they have given to you. So in fact, professor, make it easy for you that is part of FFT, the integral with the other part, and the first t is t. So that's why I'm using this law, this rule here. Good?
Yep.
Okay. So this one is Laplace of e minus t divided by s. If you remember, for the integral, we have the formula fs over s. Do you remember that? Let me write it here. If we have 0 to t, f of t dt, the Laplace will be f of s over s, okay? So the f of s is in fact Laplace of e raised to power minus t divided by s by replacing the integral. You got it? Okay, so it means now from this question, from this part, we will go down and we will have d2 over ds squared. Laplace of e raised to power minus t is in fact, what is Laplace of e raised to power minus t?
1 over s plus 1.
1 over s plus 1. Yes. So we have 1 over s into s plus 1 here. Now we will take the derivatives of these two. And I mean double derivative, first derivative and then another derivative. And then you can solve it. You will take that inverse Laplace if you want. But I think you just ask for the Laplace.
Sorry, can you scroll up for a second? Just a little bit.
Sorry?
Can you scroll up a little bit?
Yes.
Thank you.
So if you want to solve me, I can solve, but they are just your, algebra. You can do the partial fractions, you can do plus minus, you can do those things. And you can find, when you have simple Laplace terms, you can find inverse Laplace. So till here, that was the new part which I have discussed with you.
Thank you.
Okay, so let's go down. If you want, I can take the derivative of this equation, and then you can solve it if you want. Should I go with that? Yes, no? Okay, I think you are fine here. Then let's start the third question.
Just a quick question. So doing the double derivative of that gives you the final solution?
Double
this
derivative
question?
will give you a simple form in the S form, okay, of the Laplace form. And when you will have simple terms, it's easy to find their inverse Laplace.
Oh, and then then the solution. Okay, gotcha.
Yeah, that's the solution. Then you will get the solution.
I have a question.
Yes.
What happened to the integration again?
So this integration we had here, this integral,
Yeah, so we went from the integration to dividing by s, which is why I'm confused.
this integral, we
Yeah.
use the law here, this one, which says that when you have integral of f of t dt, you will use it you will use fs over s. This is the term. So integral become 1 over s and your f of t, fs goes up in the numerator. This is the law we used here.
All right, thank you.
Welcome. So let's start a third question. So once we put it simple form, we do partial fraction decomposition. When you will find its derivative, double derivative, there will be 4 or 5 terms. Let me see how many, yeah, 4 or 5 terms and 3 terms when you will solve them. And then you will do partial fractions, yes.
Wait,
And
sorry. So just to confirm, I think someone asked us already, but so this equation you have, if you just evaluate it, that's the final answer. It's just a double derivative, and then you're
again,
done.
we will take the double derivative. It will
Yeah.
come into form of s terms, fine. Double derivative is gone. You have 3, 4 s terms, and then you will make the, where they have squares or other powers, you will use partial fractions to make them simple, and then you will find your constants and you will find formulas.
Is that for the inverse?
For the inverse, yes, you have to find
Oh,
Laplace.
okay. Oh, okay. If the question asked for it, okay.
Okay.
Wait, so if it's not inverse, we just solve the double derivative.
No, it is asking for the Laplace inverse. Fine.
I know, but if it wasn't inverse.
If it wasn't, if just say Laplace, find the Laplace, then you just find the Laplace.
Okay, thank you.
Could you just keep going with the question, please? Like with this question, since there seems to be some confusion with it, could you just keep going?
But the question says evaluate the Laplace transform.
Yeah, the Laplace transform, not the inverse.
Evaluate. Oh yeah, if it is not Laplace inverse, then you just have to take the derivatives and find the terms. That's it.
So the double derivative of this would be the final solution then?
Yes.
Okay.
Okay, perfect.
Perfect. Fine. So evaluate the, I mixed it with the question number 3. Okay, fine. But if you just have to find the Laplace, do until it is said. Okay, don't do more. Evaluate the inverse Laplace. So this time we have Laplace inverse of 4 over s square into s minus 4. So again, we have used this one. This is very important. We will use this, okay? Now in the inverse Laplace. So 4 is constant. We can take it out. 4 Laplace inverse 1 over s square into s minus 4. Now this, I can write it as, it is just the manipulation, 1 over s into s minus 4 divided by s. It does not change the equation, fine. So when it does not change the equation, my space is a little bit short, so I have to manage things around. Fine. So then we have this term will become 4 over Laplace inverse. This is our fs, fine. according to that formula. So let our Fs is 1 over s into s minus 4. Taking its Laplace inverse, we will have Laplace inverse of 1 over s into s minus 4. Fine. I can write it as 1 minus s minus 4 divided by s, right? Now this one is f of t, and this is f of s and over s again. Fine, you can see that. Any question till here?
Sorry, if you scroll up a little bit,
Yeah,
there was an s square, right? How
yes.
come it's just s in the
So-
next one?
So I played with the equation. I put 1 over s into s minus 4 in the numerator divided by s. So this s will be multiplied with this s. Fine.
Are
Yes,
are
thank
we
you.
not able to do partial fractions and just solve it through inverse Laplace?
Yeah,
the
you
other
can
way?
do that.
Okay.
But this is quick method as compared to the partial fractions. You know, you have to find that you can do that as well. So here we just trying to play with the equation. So here we have again 1 over s minus 4 over s. You got it? I hope you are with me, everyone. So here we can write it as 0 to t. F of t is 1 over s minus 4. So what is the Laplace inverse of 1 over s minus 4?
E to the t.
E raised to power
To the
E to the
4t.
4t.
4t. So this is e raised to power 4t. It means it is Laplace of e raised to power 4t, 0 to t dt. Fine. I can write it as like this. Not Laplace, sorry. Just this is our function. By that rule, which we just used in the last equation as well. You remember
Shouldn't
that rule?
Shouldn't it be with respect to tau?
Okay, tau, yes, 4 tau. You're right. Fine. Any confusion?
I'm kind of confused how you like turn the 1 over s into the numerator.
Okay. So let's try it again. Fine. Question 3. We have 4 over s square into s minus 4. We will solve this question first. You have no problem with that. 4 is constant. It is out. 1 over s square into s minus 4. Now this term, I can write it as 1 over s minus 4 multiplied by s divided by s. Does it make a difference? No, it does not make a difference to the equation because this s is divided by this s. This is a over b divided by c. You write is a over bc. Okay, I can write it as like that. So for this term, again, I will use it 1 over s minus 4 over s. Fine. Same rule. Now, when I apply this term, Laplace inverse upon this one, it is in fact fs over s. So I will get e4t 0 to t tau d tau. And with this s, I will apply again 0 to t e4 tau d tau. This is the solution. You got it?
Yep, that makes sense.
So, but when you write it, try to write with the Laplace inverse and all terms. So you will be happy with that.
So do we basically, if we have like divided by s squared, we just like do this every time, like we divide
Yes.
by s?
if there is s square, you can make it double integral, okay?
But if it's like a different factor, we don't do it only for s squared, or like s to the power of something.
If you want to do the which factors, say it again.
So like we only do if like s to the power of something is in the denominator, pretty much.
Yes, I mean, this will be easy for you.
Yeah, and then when we go
Yes.
back, we have an integration, and then so whatever integration we have, it's still divided by s.
Yes. Whatever the fs you have divided by s, it means you have an integral in the function.
Yeah. I was just wondering,
And
like,
if there are
can
two
you
s squared, then they're double integral. Yes.
can you like finish the question?
Yes.
Thank you.
Say it again.
Do you mind like finishing the question after you do that? Because I'm just curious how you like put it back into right now we evaluated f of s and then it's still divided by s.
Okay, so you want me to do it again?
No,
Let
just
me delete it, and then I will try to do the question continue.
But every s you bring below is an integration. So when you bring the two s's below, you double integrate it.
Yes.
When that's how you do it
Yes.
to bring it back.
yeah, that was my question. Thank you.
Okay. Oh, that was the question. Okay, sorry, I didn't get it. So now question 4.
Sorry, so if you had like, let's say like s to the power 4 in the denominator, you'd do like a quadruple integral or a triple integral basically.
Yes, I mean, you can do by that law.
Just like theoretically.
Yes, theoretically, yes.
Also for this question, could you have split like the
Partial fraction?
function? Could you have made like, could you scroll up to the question and then I can explain? So like, couldn't you have made this like 4 over s squared multiplied by 1 over s minus 4, and then you could have done the inverse of that using convolution and then integrated? Would that work as well?
Convolution?
Like, because you can rewrite this function as like as 4 over s squared multiplied by 1 over s minus 4, and then you could do the inverse of that, which would just be the convolution of those two transforms, if that makes sense.
That,
Okay, sorry, it's okay.
right?
Continue.
Try it. Try it.
Okay, thank you.
So let's start with the next question. Any other question?
And then you multiply by 4, right?
Yeah, we have to multiply by 4 here. I just noticed that I missed it. Yes.
Quick question.
Yes.
So would we leave this as our final answer? Or do we have to like fully compute the integration?
No, I think it is enough.
Okay, thank you.
Wait, are you supposed to have two? Did you mean to have double integration there?
Sorry.
You have
Yeah,
two
both
integration
of them.
signs.
It's
Yes,
supposed to
we
be
have double integral here.
Wait, can you explain how it's double integration?
Because there was s square, fine, in the denominator. We use first s with the rest of the term in the numerator and one s in the denominator. So first integral came, and then the numerator term, there was another s. So we use it to find the second integral.
Okay.
It's like s. If it was
One-
s to the 3, would we have 3 integrals? Like if it was s cubed.
Yes, you can. I mean, this is if you were in your labs, this was a question discussed by in the labs as well. I think not this lab, the previous lab, 6th lab or 5th lab, we discussed it.
And just to confirm, so if we did it this method, and our final answer would be 4 to the double integral of e to the 4 tau d tau. That's
Yes.
the final.
Yes.
Okay. We don't actually have to do the integrals.
No, I don't think so. You should do the integral.
Okay.
Until they ask you. It's fine. So let's move to the next question. Oh, sorry. Okay, question number 4. Yes. Okay, question number 4. Use the Laplace transform to solve the integral equation. So this time we have y prime plus 2y, which is function of t, 1 minus 5, 0 to t, y of tau, and d tau is missing, and y0 equals 0. So we will apply Laplace. So this will become sys minus y0 plus 2ys. And on the right side, we will have 1 over s minus 5. This is again, we are going to use y over s. Fine, by using the rule which we just discussed. Okay, I will send the copy of the notes and the recording to the study who has arranged this. So they will share it with you. Don't worry about that. So this is the first equation we have made. Now this is 0 term. This is 0. Fine. So we have s plus 2 plus 5 over s y equals 1 over s. Fine. Let me write it again. It is very confusing. Why? So any question till here? This was easy part. So we have s squared plus 2s plus 5 divided by s multiplied by y equals 1 over s. S will be cancelled. So we have y is equals to 1 over s squared plus 2s plus 5. You have the Laplace. Now you have to solve the integral equation. So we cannot stop here. So let me see my question number 4. Where it is gone. So fine. So what we will do here, we can make it 1 over s squared plus 2s plus 1 plus 4, right? So it will be 1 over s plus 1 square plus 2 square. Now you can take the inverse Laplace and find your solution. Fine. This is just, you have to use the formula. Any question about this problem?
So this is like the translation one, right?
Sorry?
This is like the translation one where you have like e to the minus t.
Yes. And there's 2 also.
So like it's 1 over s squared plus 4 and then multiply by e to the minus t. Or something like that.
So I don't have the formulas with me, but there's formula and you will find it, okay?
You know if we're given the formula for this and the similar?
Oh, they will give